Welcome back. How's it going, everybody? Gonna dial down this music a little bit. Just try to change gears to something a little bit more laid back. So, gonna get back into some destruction type stuff. What's this? Beers? Cheers for beers? So kind of picking up or continuing on some destruction, like RBD type stuff today. I'm gonna go back into some basics and kind of build from there. So the last destruction stuff we were doing, or RBD focused, was this terrain destruction. But before we dive completely into that scene, it's like a little complex or slow to work with. Just going to be doing some more simple, basic kind of stuff. We'll give some people a chance to get in if they're running late. Some other stuff I had. So this was interesting kind of destruction reference I found. This is a pretty cool approach that they did for this shockwave or like terrain destruction at the start. Like there's like a delay before the smoke comes up. So I think that's just in terms of visual design, it's a pretty cool approach. Let me see who this is. Is this Camholes? He has a lot of destruction content, right? So this is a pretty cool video from him doing the like edge detail and stuff like that. Then of course Stephen Nipping with Applied Houdini, the Rigids courses that he's doing there. That's like excellent resource as well. So I don't know, I'm not planning to go like super deep into any of this stuff for right now, but if you guys are more interested in doing like super in-depth destructions, definitely Keith and Stephen Nipping are super good resources to have for that kind of stuff. Yeah, so I was just looking at this this reference right here. This might be a weird link, but it should work. This blog post is pretty cool. It just has like a lot of collection of different anime breakdowns and stuff like that. But yeah, I just thought it was a cool idea, kind of delaying like a secondary reaction. So you get to actually see the cracking in the detail and stuff like that. It seems like, especially sometimes sometimes working at visual effects places, it was like different departments or different people that would handle different tasks. Like I think, for example, at ILM, the one department would do the actual destruction, and then a different department would do the dust and volumetrics. So they were always frustrated. They were like, I spent all this time making all these detailed cracks and little pieces. You guys just covered it in dust. And it's like, can't see any of the detail and stuff like that. So I thought this, I don't know, it just kind of caught my eye. That it was an interesting idea to like just visually make everything more impressive and stuff like that. So good resource. Another thing I usually do is just look around on Vimeo. It's like super weird to set it up now because they kind of messed up their search algorithm or whatever. But if you do this sort by date, I don't know, it's kind of hard to set it up by the filters or whatever. You can see like the latest stuff that people post. Sometimes there's some interesting destruction things or whatever in there. It's a good resource just for inspiration and stuff like that. YouTube has some good content as well, but I don't know if I haven't found a good way to search it. by date or anything like that. Yeah, so Vimeo, I don't know if you can still do it, but like I usually type in Houdini and then refine by, I don't know, these categories is kind of weird. I don't know how to I don't know how to sort it using those filters, but like I have this URL saved in my browser or whatever. So if you use this, it's like sort :date or whatever. So it's a good method to use. And then you can see like the latest, just chronologically sorted or whatever. Yeah, so that's cool. So I've been working on some glass kind of stuff in my free time, doing caustics and that kind of stuff. So I'm trying to finish. I've been making, where did it go? So I'm trying to finish a couple of these kind of style ones or whatever. It's actually not that bad of a render time for these caustics. It's with Redshift or whatever. So it's not brute. I don't think you can do brute force caustics like where they're actually happening at render time. It's like a bit of a pre-pass because it uses these caustic photons. I don't think the renderer traces like caustic rays at actual render time. You can get pretty good. You get good results with this. It's pretty cool, like the dispersion and stuff like that. So trying to finish up, get one more kind of image for this series. It's kind of like Art Deco style, or I don't know exactly what the name is of that interior design method or whatever, but just trying to get one more like punched in. So this is like the wide shot, detail shot maybe in mid-range, or just a series of like 3 or whatever is usually. I've been trying to do that more recently, is get 3 different angles or 3 different shots to showcase some of this stuff. Yeah, it's just been trying to make it kind of very refined, like simplified and, I don't know, elegant, or I don't know, the expensive, luxurious. So that's that guy, trying to finish that up soon. Get rid of that window for right now. I don't know if I want to start with this one. Probably just gonna start with a fresh Houdini scene. We'll jump in. So we might have some new people in, looks like we got some new people in the Discord server. So if you go to the Twitch redesigned their layout or whatever, but go to twitch.tv/JohnKoons. They like redid their panels or something like that. But if you click the Discord link right here, this will bring you to the Discord server. You could get questions answered, or I have all the archives of like old streams and Houdini files and ask questions or all that good stuff in there. That's a cool thing to do. Definitely do that if you're a new viewer. It's still working out the schedule on there, I think, but get that figured out eventually. So I was using Streamlabs because Twitch didn't support it directly, and then switching over now because they have it built into their profile section. Yeah, I tried to update my profile section and all of that. I don't know. Seems like I'm not a big fan of their new layout right now, but we'll see. It might grow on me. So I'm just gonna start with a sphere, and do kind kind of a simple destruction or cutting of it. So we'll keep going with this Boolean we were talking about last stream. I'm just gonna try to make some simple kind of cutting stuff. So we'll just do a box maybe. Then this guy, just set it to shatter. Get the box. So we just need to copy a few boxes to the surface or around that sphere. So we'll do maybe like 22, not 222. 22 points. I think these guys are flipped around. You just do Shift R and it will reverse the inputs of your nodes. And then just to get these spun around in different directions or whatever, instead of, you just do attribute randomize, and then instead of randomizing the color, we randomize N. Then I usually just set that to direction. You get random directions. See what happens with that. And then if things look black like that, usually you just need to add normals. Sometimes actually adding them before you cut it will help the Boolean node out. Jack, how's it going? Thank you for the thank you for the cheer. I'm still figuring out the Twitch UI and all that stuff. I think they upgraded my account somehow to affiliate or something like that, so people can subscribe if they enjoy this. If you have Twitch, if you have Amazon Prime, you can link that to your Twitch account and like subscribe using that for no cost to you. I think I'm doing well. Enjoying the weekend. Getting some good weather here in San Francisco. So if you add these normals, this actually helps the Boolean node do its job. Like it has a better job at figuring out the inside and outside of geometry, and when it cuts things, it will produce better results. Yeah, it was like a week, 2 weeks ago or something since you were in here. I took kind of the entirety of last week off just to get caught up on work stuff and kind of take a little break. So then I usually do this assemble just as a quick way to kind of visualize stuff, create packed. And then if you just want a quick way to visualize this, you can do another randomize and just set that to primitives. So this time we will use the color. In Bangkok. How hot is it? You do stuff in Celsius or Fahrenheit? It's pretty nice. Sometimes it gets too hot here, but we're doing pretty good today. Usually don't even have to use air conditioning or anything like that. It's just nice kind of breeze and stuff like that. So the other thing we do sometimes is exploded view. This way you can examine the insides of your pieces and stuff like that. And the other useful thing after what I did with this assemble was create packed geometry. So every connected kind of unit or piece of geometry turns into a packed primitive. So you can, if you middle mouse on the assemble node, you can very quickly see how many pieces you have. 110? That's like too hot to use the computer. Like your stuff will overheat. What was it? I don't know if I have this. So You get into critical range with just at like room temperature of your devices. So this thing usually runs like pretty hot for me. Sometimes when it's too hot, I'll like notice when I turn on GPUs and all of that stuff, it will make my room even warmer. So we'll start with this. This is for people just coming in. I'm just kind of working up from a simple fracture setting, and then we're going to apply some of these techniques to where we left off with this terrain stuff. So just kind of looking at this, like some of the patterns and stuff initially is pretty cool, but it generally looks pretty bad in your simulation when you just have like all of the destruction happening on one frame. Like it's kind of, you just like, everything is split up instantaneously and nothing else residually breaks or crumbles. So that's something we want to address or fix. And then like some of these pieces is just unrealistic how they're so big and then they just wobble around like that or whatever. So we'll start with the DOP network. These ones here are just visualizations, so I'll just set them aside and plug that right into the first input. So how do I push those RBDs? In that, I lost it. Where did it go? In that video, it was just initial velocity. So at the start of the simulation, or we could just show you right here with this packed RBD object. This has the inherent velocity from point attribute. So you use this, and then you can set velocity and angular velocity using point attributes. So velocity uses the V attribute, and angular velocity uses the W point attribute. So instead of geometry source set to the SOP path, we'll just do first context. Then I usually do solve on creation. We'll do a bullet solver, or sometimes I think it's better to do the rigid body solver. So this one has these extra inputs that are nice to have, whereas this one you can't. It's just a little bit goofy to use or whatever, I guess. So this comes in, we have the shape showing up well now. Can add gravity. Usually I do the pop force method of gravity instead of setting like the global gravity or whatever. Because this allows you could change the gravity per point or per shape more easily. And it looks like we have some issues here. I think that's relating to how we fractured it. It doesn't have the best collision shapes right now. I'm gonna add a ground plane. And then I'm always setting these up such that the static objects are on the left, and then our dynamic rigid body the dynamic rigid bodies or whatever, they're on the right input, because by default these merge is set that way, so that it's not necessarily multi-threaded because they don't really do anything. They're not like they're just adding data to tell the solver what to do, and then it would be up to the bullet solver to be multi-threaded. If I go up here, I'm just going to right-click on the DOP network and go to spreadsheet. And the spreadsheet for the DOP network is a little bit different than geometry spreadsheet because you have more information. So one thing you have that's pretty nice is this effector matrix. It's a little bit complicated to read at first, but it's kind of like a spreadsheet showing which objects will affect what and everything. So that's what I meant when I was saying that the order of this input matters. If I switch these around, you can see that these things are no longer going to interact in that method. So this is a good way to see like which objects are affecting other objects with this effector matrix. I think if you go to the, let me get another window right here. So this is, it's going to be kind of hidden. Oh man, is this comes up for everybody, or they gamed my algorithm? Somehow this comes up for people's Google search results as my Vex documents. This is the, the spreadsheet time. Welcome to Microsoft Excel inside of Houdini. So if you just go to dynamics here in general, they talk about this details view pane right here a little bit more, and then it's like super, they don't have it laid out that well, but this is where they talk about the effector matrix here, so you can get a sense of what's actually happening with that. So basically sorry I got sidetracked there. So with gravity, with this pop force, what it does is if I go to the geometry of the RBD packed object, that will basically add this force attribute. Somewhere it's here. Right here. So I think I might have to let it go one frame, like play it one frame, or it's possible that the solver is like zeroing out that attribute. Might also, let me just take a closer look inside of here. So this thing is changing force, but I think the solver is updating it and clearing it out before I can view the results like in my spreadsheet. So that's what this pop force does, is like per piece on the geometry, it will add this force that you want. The other gravity right here, what this does is it adds this global like forces section here that's basically has this one like vector or value here to apply to everything within the geometry, but I can't modify it per point, per piece, or per group or anything like that. These groups aren't SOP groups. This is like a DOP. It works a little bit differently, and I can't add just like certain pieces of this rigid body object. It gets complicated pretty quickly, just the way that DOPS is organized. But that's why I don't use this gravity. They're both basically instructions that get sent to the solver to tell it to do like apply the gravity Newton drop the apple on his head kind of force, but just the amount of control you have over the two of these is different. I believe they take into account the mass. The mass is just calculated by the size of the pieces. This one, it has this ignore mass turned on. So you might want to do some tests and stuff depending on the results that you're after with that kind of stuff. Hopefully that makes sense. So I'm just gonna fix these issues right here. I think what's happening is that some of these shapes are not concave. So like when we look at the collision geometry of this stuff, I'm just gonna go back to the first frame so that it updates. If we look at the collision geometry, like this actually does a shrink wrapping So these things are sticking through each other or whatever. That's another kind of complicated thing that I'm not ready to get into that territory right now of ignore mass by default. So this is why this stuff is kind of exploding or whatever. No, it's good. Questions are good. So one way we can get around this issue or whatever of the pieces collision geometry sticking through each other such that it doesn't break apart like this, we just fracture it some more times. So if I do for each primitive, this is a useful way. Not only do packing the geometry makes it easier and like more optimized to simulate, but you can also now run these for loops over things, so that each time this loop runs, if I go to single pass, now it's just running on an individual piece. And then if I want to, I can unpack the geometry here so that I can access all of it instead of just the packed kind of reference to the piece. So what I can do here is scatter more points, and then you can kind of get a little. You think the music is a little too loud? Let's dial it back a little bit. How is that? So what I'm going to do here is just scatter. We could do 4 points or maybe 6 points, and turn off the other settings again. And then with these ones, what I can do is maybe, because that the Boolean node has generally a problem where it will create these odd looking shapes. The concave, anytime you see like an intrusion like that, it's a cave or concave geometry. So to get around that, what I usually do is another fracture, but this time a Voronoi fracture. So I just set this to polylines, and then do the Voronoi split. And this guy we want to create interior. Usually I will add those attributes just because it's helpful. So now if we grab these nodes again, take a look at this, we have another layer or like another iteration of fracturing happening. Usually with this normal node, you'll need to recalculate the normals after things get fractured. And then what's useful about these attributes is that you can use them to find whether they're like new fractured faces or not. So this CLI PPT, if it's equal to -1, then you can know that it's like a new piece. So if I do equals, I think it's equals -1. And then if I just do exclamation point at the start, that's like everything except -1. So I could do maybe a color down here, and it might be a little bit more clear to visualize stuff this way. So I'll just grab that. We're going to do primitives, set that to 0. Let me make sure these. I think this. Something's a mess right now. Let me just gonna go into my spreadsheet to get things a little bit more visible. So this is the CLI PPT, the clip point attribute. you could see it's, I'm not sure how it got set to -1 for everything right there. So some of these are not -1, and I think those are the existing faces. Maybe it's this. I'm not sure. Maybe let me try this. Delete all existing? I don't know. I'm just gonna I'm gonna skip that for right now. Might be like a caching issue or something like that, but basically this is why I was doing that, is just to create new normals for those fractured pieces. So if I turn it off or turn it on, you could kind of see the difference with it. So I could turn off the single pass now, and basically what this is doing is adding 6 more layers or 6 pieces from our original source pieces. So we do that, we do that. You can see we're up to like 2,000 or something like that now. So one of the things that you can do that's pretty useful is like you can start to hack around with some of the geometry attributes. So you can use this just so that the solver still thinks that there's the same large pieces, but you're just fracturing it to help out the collision geometry a little bit. So I'm going to increase this just to 12. So now we'll have 12 pieces making up all of our source pieces. So we could use this directly if we go into here. Looks like we still have some explosions. Let me see if switching this seed helps out a little bit. Sometimes this collision padding can get messed up for, you think it's the small pieces? I think you might be right. So sometimes this solver gets messed up with the small pieces. There's a few different ways to delete them. You could measure them with this node. So if I set this, oof. Oh no, we crashed. Let's get back into business. The measure SOP, also known as the Crasher Houdini SOP. All right, let's get back into action here. All right, we're back. Let's turn that one off for right now. So you have a few different options on how to measure all of this geometry. If I go into the spreadsheet, now if I look at the intrinsics, it has this bounds attribute that's like a bounding box that automatically gets added for packed geometry. I've had some issues in the past though where this information isn't always 100% accurate. Basically, like sometimes this packed primitives, the bounds are calculated improperly. So I'll tend not to use that. You also have this measured area, perimeter, and volume. So area is like surface area, perimeter is edge lengths usually, and volume is like 3D space that's taken up with the 3D volume of the shapes. So if I just do measured volume, it looks like that's empty. It looks like all of these are empty for these. They might not work for packed geometry. They might not always show up. So let me take a look at this. So now we have them before the geometry is packed. One thing that you can do that's useful, so we just have the P and N attributes. If I do the connectivity, what this does is it just finds the 3D connectivity. It's what gets used inside of here to find each fracture piece. So we can do connectivity before we pack it. Set that to primitive. Just get this spreadsheet back open such that we're properly examining. I don't always have this open if I'm just doing more like design or stuff like that, but with fracturing, it generally I don't know, the RBD and stuff, you generally turn into a Excel spreadsheet madman after enough time. So this connectivity is making a class attribute that's unique for each piece. Then you can also do the poly soup, and now each connected piece will be under its own individual primitive, but it's a little bit different than a packed primitive. And you can see it's a little bit different because this should now actually have the measured area and measured perimeter and measured volume as well. So with this, now we can use these intrinsics inside of the split SOP. So if I just do at intrinsic, boolean measured volume, then I just have to compare this to a threshold. Now you can see that I'm isolating the smaller shards that don't have a very high volume. So I think Shades of Orange was correct that sometimes when you have like pieces that get too flat, too slender, or just too small, it can cause Bullet to blow up. But maybe we don't necessarily want to delete these. We want to like attach them to the nearest bullet piece that it finds, so that the solver just thinks that they're connected and they're all the same piece. Let's take a look at this threshold. Try out some different things. So like this piece right here gets kind of you're always right, I think. I've never heard you say anything wrong yet, so so like these little toothpicks or whatever here, they cause issues for the solver. The Boolean in general is a node that is a very nice feature for Houdini and everything like that, but it does have problems of creating like non-manifold geometry, like very problematic geometry for future operations and things like that. This guy right here is a pretty flat piece or whatever. So we could even just test your logic, I think. If I invert this and we just assemble, got rid of the smaller pieces. And it looks like those we're missing, we have some holes because we deleted pieces, but we're no longer getting like the stuff flying out of the bottom. And now our shape is no longer completely fracturing or whatever. Like it's not blowing up at the start, if that makes sense. But it's falling apart due to there's no constraints. We don't have any glue or anything like that. Every piece is treated independently or whatever at the start. So we'll just save right now. It's a good before we crash again. It's lucky to have those crash files. This is gonna be 2020, 2020, 2020, June and 13th. We'll just do fracture basic. This guy we could just do like a limb. I don't know. I wish there was a spell check for these nodes. Eliminate small pieces. So if we want to visualize, now you can see these, we have the small ones over here. So what I can do is assemble, but I'm not going to use this also to pack the geometry. I'm just going to use this to assign name attributes and all of that stuff. So before we use that, I'll just turn off these the extra intrinsics. We don't need to look at them anymore. So we have all the pieces now for each connected geometry. What I can do with these extra chunks over here, we can do a wrangle and we can run it over primitive, or we can skip that. Don't need to do code just yet. So we'll just do attribute transfer. So sometimes I get carried away. Kieran, how's it going? So I'll just do attribute transfer, and this, what it's going to do is spatially look at this input and find the nearest name and grab it or transfer it, copy it over. And then if I do another pack right here, whoops, this is the wrong one. So this is for points. We just do pack. And then enable name attribute. You can see we have 62. I don't want to do it just yet. We want to merge this guy over here. So we have 251 total pieces. But if you look right here, we can count, we had 376. So basically, we found 125 pieces that were too small, and we glued them or just cemented, like they're never going to break off because they're considered the same object now. And they'll always be attached. So we might be able to find some in here because these would all be getting exploded and colored the same way now. So if I go to the DOP network again, play it, we're not getting any stuff shooting out of the bottom, and we're back in good shape. So the reason things look a little bit jittered at the start is just because I have that solve on creation frame on. If you don't want that, you just uncheck it, and then the first frame will be like a clean frame or whatever. Depends on if you're rendering stuff that way. So this is a pretty useful technique to fix those artifacts or those problems that are caused by the Boolean node. We might want to use that later. So I'm just going to reorganize this stuff a little bit more. So this connectivity, just to review, go through stuff again. This is making a class attribute for connected chunk. The soup is basically making a primitive per class attribute. So anything that has a unique chunk number or chunk connected ID gets encapsulated in a soup primitive. It's like a special kind of data type in Houdini. And then we're doing that so that the measured volume is calculated per like connected chunk. So if you just do that before, what's happening with this is that each individual face or primitive is getting the volume and all of that stuff measured. So it's unusably small, or it's unusable because we don't want to look at individual faces. Just to illustrate that, if I connect things up here, you can see everything's like super garbled up because we're not looking at the volume per connected piece. We're just looking at it per face. So it's not usable at that point. Then this assemble, we're just assigning the name attribute. These are pieces too small to sim. And then we're getting the nearest name. And by assigning like the nearest name when we pack it, everything gets put or assigned a packed primitive based on their unique name. So we're basically saying just include this in the nearest big piece and attach it and simulate it that way. So we might be able to visualize things a little bit if I go to randomize right here. This guy is going to generate a random color per primitive, but it's before we've done the magic of like reconfiguring attached pieces and stuff like that. So when this splits apart, we should be able to see colors that stay together, but they're different colors or different pieces. And then this way the smaller chunks or slivers or whatever will stand up. So generally doing destructions and really diving deep or whatever, it gets super technical and boring and stuff like that, but it's essential in like debugging and figuring out what's going on with your RBD simulations. Otherwise you can have like little problems that you never fix, but they're always like just every other thing you try to do later on down the line affects things and makes it worse. So let me just try to increase this a little bit more to illustrate it better. So what I did there was just increase the threshold. And that's basically isolating more smaller pieces that we're going to attach to the bigger ones. I'm trying to find some areas here that, like visually, we can see the small ones sticking to bigger colors. I think. I have hand animated some RBD pieces and stuff like that before. So like these guys here, they look like they're stuck together. Yeah, it's hard to figure out. So Shades of Orange is talking about how the art director or supervisor or someone like that will hand pick individual pieces that don't seem to be performing well. It depends how much people are set in with what they like about the other aspects of the simulation, but that generally does happen. There isn't a good way to I guess you could re-simulate those in like a secondary simulation or something like that, but it's, so you can see what I mean here. These guys are glued together, but they're different connected pieces. So this is that kind of workflow that I was talking about. We could do a similar process over here. Blasty. Yeah, when you guys use this right here, it's pretty good. You would find nodes in the network and stuff like that. So when you do have Blast 3022, Transform 85, Time Shift 64, all of those, you can keep track of them a little bit better. So this stuff over here is just our example workflow for finding small pieces and gluing them to nearby bigger pieces. Sometimes I'll do these net boxes or whatever to make stuff a little bit better. So that shortcut is just in the top right. There's this magnifying glass to find a node. It's right next to the display options for the NetGraph editor or whatever. I don't know if there's a hotkey for it, but it's just a little magnifying glass. I think you can even do some advanced kind of stuff with it. Like, let me see if I have, so these normal nodes, I think I've used them a good amount. I thought that there was like a rename, but it doesn't look like there's just like rename all of these to something else, but I don't think that there is. But you could do even, whoops. So there's too many magnifying glasses. So you could also search by, whoa, we got too many of these guys. You can search for parameters and stuff like that of the actual nodes, and you get very like carried away or whatever with that one too. So with this guy, we go over back to this chain. Whoops. Let's just get my other nodes back here. So with this one, what we were doing is fracturing the pieces to avoid the concave convex issues and all of that stuff. So it's pretty useful to be able to do this. Like if we look at it before, we have some big chunks here that are oddly shaped. The simulation is never going to enjoy working with those, or it's never going to figure them out that well. So one way to fix that, or one thing to do, is to just fracture them a second time, another iteration, and then the pieces, the more that you use the Voronoi fracture, the more they will start to become convex. If that makes sense. It is true, but it's hard to kind of think about or conceptualize. But basically, the Voronoi split will always generate convex geometry unless you feed it concave. But the more times you use it, or the more chunks you create, the more likelihood is, or the more the pieces will become closer to convex pieces. So we'll move that. We grab this solver again, and go back into here. So it's going to be a little bit slower to simulate with And then we still have that issue with the small pieces. So what we can do is just copy the nodes over. Yeah, the convex decomposition is pretty good. There's also the like fill with spheres. That's a useful one. So both of those are pretty useful techniques to avoid these kinds of issues. Is it the convex decomposition? So yeah, I guess it's the actual node that you can do as well. But there's also a shelf tool for it. So this one is looking for the name. It might not work with the packed geometry. So I might have to do unpack. And transfer over the name. I think it's working now. I haven't used this ever before, so I might be leading you astray. I'm not sure. Whoops. I think that there was like a masterclass or something like that when they first released the for each network. Maybe these loops. It was something that Jeff Wagner did that was pretty useful. It might be this one. I don't know. I have a feeling it wasn't the Jeff Late one. We're getting a little bit too technical. You have one right here. Just this area of the documentation. Feels like some areas they've documented. I like this this animation at the end. Yeah, so they switched their for each network to be these loops or whatever, I guess. I think that Matt Estella, the CG Wiki, he did some sections as well, and maybe if you just do this for loops. It kind of depends if you like to watch videos or read stuff. He does a good job posting examples and just doing little, like, it's almost like his website is better documentation than the Houdini documentation. But there's, I don't know, he just has a good eye for making things that are like interesting to look at, and then you want to figure out how it's working or whatever. Yeah, so all this stuff is pretty good. There was some. This is it, I think, the geometry workflows. So I think that's what that page of the documentation is based off of. Yeah, it might still be better than the Maya docs, but I don't know. To me, the best is like the Arnold documentation. I don't even really use Arnold that often, but just their documentation is like to figure out how renderers and stuff like that work is pretty good. To me, they do the best job of having like really good, nice looking pictures and just illustrating very clearly is like what's going on and all of that stuff. It's amazing. But yeah, whoever is designing the Arnold documentation, they need to Side Effects needs to steal them. I think even, I don't know if they've redesigned their website, but their website just generally has always been pretty well organized with like not a lot of clutter. The gallery, they do a good job of kind of curating this and just making sure that it's always like pretty interesting results or whatever. It's almost like this. It's like the side effects splash screen. Someone recreated it with Arnold or something, maybe. All right. Lee Griggs, yeah, I think he's the mastermind behind the Arnold stuff. He's like an artist, or I don't know if he's only an artist. He might be a developer as well, but he works for them full time. I think just to generate like documentation and images and stuff. Yeah, so I haven't looked into the convex decomposition too much, so I'm not exactly sure how to finish setting it up right now, but it's another thing that does kind of like what I'm trying to show with that one there. So we'll just keep going with this. So again, the issue here, when I played it, we had the small pieces that explode. So we can take this workflow and copy it and reuse it over here. But again, we don't want to feed it packed geometry because this is kind of like a replacement of the assemble. So we'll just do that. And then we fixed that issue of all the pieces shooting out and flying everywhere or whatever at the start of the simulation. So that's Mr. Shades of Orange was definitely right with that call on the small pieces. One thing you can do is if you just do Shift C, then you encapsulate stuff in subnetworks. So instead of this just being like basic assemble, this can be like assemble maybe eliminate. I don't know if I might be spelling that wrong. Small chunks. So this is another way I'll work sometimes too, besides it's the same idea. These things you can minimize and hide or whatever, and this you just like double click to go inside. So that's one thing you can do with these. Another way to work, I believe, let me think. So I might, whoops. Uh-oh. Let me put that back. All right, let's try that again. So I'm just gonna make a copy of that for loop. Another way that you can work with these for loops is like, let me think real quick. So what I'm gonna do is use my assemble fixer first. It's correct, thank you. I felt like I was missing another E or something like that, but my instincts were correct. So if we do this first, let me just make sure. All right. Let me do some housekeeping. Just leave that one over there. So I just wanted to make sure that this stuff isn't packed yet. So this guy is gonna set aside the small pieces. So now when we're doing this for each, instead of each individual chunk, now we're only operating on the chunks that we've deemed large enough to simulate. And then what we can do when we're running all of our fractures, if we just go into a single piece, maybe. Just gonna go inside of here real quick. I don't know, I feel like these colors should be a little bit different sometimes. Maybe, I think when I'm packing, so that's what's happening. So when I'm packing the geometry, the colors are all getting like promoted and moved up to the primitive level, if that makes sense. Let me see what happens if I just promote. Sometimes it still doesn't work. Sometimes Houdini gets a little bit funky with colors and pack primitives and stuff like that. One thing I do is kind of sometimes if you unpack stuff at the end, then you can see like what the real colors are. This guy should be unpacking. I don't know, I'm not gonna worry too much about that right now. So what I want to do here, I just set this to operate on a single pass or an individual piece. So now I'm cutting it into smaller pieces, but what I can do, we look at this input right here. Okay, so I'm gonna do an assemble. This one, hold on a second. Getting myself into a mess. So one more thing you want to do, usually after you've assembled things, is to have a name attribute. So if I assemble, this will just create. Oh, okay. So I just want to transfer my name. So now it still exists. And then it depends, but usually this is where things get kind of frustrating. So this bullet solver wants the name to be a point attribute, and usually, like by default or some workflows, it gets attached to the primitives. So we put the name, move it to point. Maybe instead of deleting original, we'll just make a copy of it. So now we have it in both places. You just have to make sure it's always matched up if you're working that way. The reason I'm doing this now is because I want to copy the name attribute from the input. So basically all of these new chunks are getting the name of their parent or the piece that they were generated from. So if I do name, now you can see we have a bunch of piece 3s. We can do maybe randomize. So pretty cool. Crystal or something like that. But this randomize, I want to gonna reuse these nodes. And then this one, we're gonna make it a primitive. So even though these are different colors and everything, they'll still get the same name attribute uniformly. And then if we do a pack, we'll do this with the name. We're only getting one piece or one packed primitive. So all of these chunks are just getting represented by one shape. So if I make another copy of the DOP network, we simulate, the solver thinks that it's all attached. But the collisions will be correct even if they are concave or convex. So with this collision geometry, hide some of this other stuff. you'll see that it's still wrapping each of those pieces individually instead of all at once, I believe. You also have this option which can be useful. So you can describe like a more complex geometry, but the solver will still treat it as one object. So hopefully that makes sense. I didn't do the best job of explaining it. We'll try it with all of these pieces and see what happens. Didn't work. Let's go back to the defaults with that collision padding. So something's amiss here with our names. So I believe it's the issue of points and primitives and that differentiation that I was warning about up here. So we have we want to just recalculate or make sure that these are on the proper geometry. So with this copy, we just have to be careful because it's only grabbing one aspect of things. So let me get this one again. Something's amiss. Oh, I did it wrong. What a blunder. Alright, I think I was mistaken with that one. So under this pack node, instead of packing by name, I was just trying to transfer the attribute. It gets a little bit confusing, this bullet and all of that stuff. But hopefully you can see now what I'm talking about with simulating these as we're basically telling the solver treat all of these larger shapes as one piece, but then with the collision geometry, it's able to break things down into smaller chunks and represent things that way. So does this kind of make sense? Hopefully. I feel like we're getting lost in the sauce. Too much of this technical stuff right now. So I think the bullet solver and everything like that is pretty efficient at working with these geometries that are smaller shapes. Yeah, some people love the sauce. I don't know if everyone enjoys it. So the other thing we can do with this stuff that's pretty useful, I think you can get away with pretty high subfractures or whatever. So like if I'm cutting each initial piece into 32 smaller pieces, we're still packing it, so it's not necessarily more, the collision geometry is more accurate, but the solver is still simulating the same amount of pieces, and it will still go pretty quickly. So hopefully this kind of makes sense. The other thing we can do instead of treating all of these like they're connected, like what I was saying earlier, we kind of cemented these all together. What we can do is instead is start to use constraints. So then if we need to, we can release these. It's a little bit slower for the solver to calculate because instead of doing 111 pieces, well, each of these will actually be more pieces. But it can be more realistic for like things breaking over longer periods of time. So we still want to disable those small chunks. I'm just gonna grab this tree, move it over again. We'll just save the file as well, just in case. So there's a lot of bookkeeping. It's a lot of spreadsheet operations that we're doing, but you really want to make sure you know like what's going on under the hood, and then you can like optimize and get a lot better results with fractures, basically. So I'm going to go back into single pass mode just for one chunk. And then these ones here, I'm trying to think of the best way to set this stuff up. Let me let me take a break real quick and I'm gonna get some water while I think about this one. All right. Sorry. I don't know if this is it's a bit of a struggle to get through all this stuff. So we have this connect adjacent pieces. This one gets used to build the constraints. There's different ways to set this one up. Usually I'm using adjacent points, and it works best when the geometry is like actually packed. So if I just do in assemble, we have 32, and then the hell is going on here? So I think this is the one I'm usually using, adjacent pieces from points. I think so. So this one we can use to glue things together this way. And all of these pieces will be treated as connected. So what I'm trying to do here is, instead of this one I'm referring to as cementing, where we have, let me randomize this again just to illustrate things a little bit better. So this is kind of what I meant by packing and unpacking or whatever. I think we have to unpack and promote. So these I'm calling cemented together, where it's the same color. Even though we've fractured these, they're considered like always attached. And what I'm trying to do over here, we're going to glue these together. So instead of a cement, the glue is allowed to break over time. We can manually free it using attributes or techniques or stuff like that. Or we could like allow it to get broken by impacts and how hard it hits things. So if we want this stuff to be able to be released if a big enough force hits it, then that can happen. So let me think about the best way to set this up. We can do it. Kind of like this, and we have glue for these pieces. Might be might be time to bail on this, I don't know. Let me see. So let's see if this, trying to do a poll in the chat. Let me see if it works. Do you want me to keep going with this super technical stuff and push through it, blunder through it? Or should I go on to something more visually interesting and get back to some fun simulation related stuff? We have any voters in the chat? We got some keep goings. I just wanted to test out the polls as well. We got one for visuals, one for keep going. Got two for keep going. So maybe I didn't even phrase that poll properly. I'm gonna hold off on this one for right now. I think I need to do some research on my own time before I don't want to waste everyone's time, like maybe doing things wrong or whatever. So I'm just gonna delete this shit, get it out of there. We'll save this file here, so this is all of these things here are pretty valid. It's pretty useful. I'm gonna hold off on some of this technical stuff before I misinform people. And we're gonna go. We'll keep going in this file. So I'm gonna talk a little bit about velocity and doing some of that stuff. So like what I was talking about when I was looking at this video, this little flip book, is that we want to have a gradual explosion instead of this first frame burst where everything pops kind of like that. So we'll just set that up with a quick kind of example. I usually get rid of that stuff. You just get a more interesting distribution of nodes. And then if you're doing a 2D, if you're doing a 2D thing, you just need to do triangulate 2D. And then you can still do Voronoi split if you want. Where did it go? And because it is 2D, I'm not going to create interior surface. One thing you can do that can be pretty interesting is like if you add some resolution here. Let's go up a little bit higher. What we can do is, I think I've used this trick for other areas, but we're going to make a copy of the point position, store it, freeze it as rest, then we could just do maybe a VOP, crack one of these guys open. Then if you do, it's a bunch of different ones, maybe this anti-alias noise. I usually do this vector to vector 4. Whoops. And then just make sure that this is giving us a 3D position. And we'll add that to the point. So we do this warping or distortion of the surface after we've captured or made a copy of the existing point position. So with that, with the rest node lets us do, anytime we want to, we can go back by swapping the rest and the deformed P. So if we look at the attributes here, we have 2 copies of like regular geometry and noised up, folded, wrinkled geometry. But if we do the split when things are wrinkled like that and then revert back, then we kind of get an imprint of that noise. So we get like this more interesting fracture patterns. This breaks the convexivity. Maybe that's the right word for it. But so now we have some concave problems. We could fix that with the earlier workflows, or maybe it's not a big enough issue that we don't need to worry about it for right now. And then sometimes you do get like little areas there where if you deformed stuff too far, you can get some holes or some gaps. So if you do less noise, that can fix it. I think another way to fix it is if you have more or less like resolution, you can solve that issue sometimes as well. So if I just have a lower resolution shape, we still have some tears or whatever. Let's go up to 256. And then we just make those holes a little bit smaller. If you want, sometimes what I'll do with this divide node, you can do, instead of convex, this will like turn everything into triangles basically. So any n-gons like that, or even quads, it will turn them all into triangles. But instead of doing that, you can do removed shared edges. And now each of these pieces, or each of these fractures or islands or whatever, is a single primitive, which can be useful to work with. So let's go up with these pieces a little bit more. Maybe we'll do like 6. I don't know if I'm gonna do that. It might be too many for right now. Let me do 100. So we just have these random kind of distribution. And then another thing that you can do is, I like the Voronoi fracture sometimes because it lets you like really sculpt and design your fracture pattern. So like if you just take a sphere like this, turn it into a polygon mesh, and then with this copy transform, I'm just gonna make some more copies, kind of like the little icon is showing. So each copy, maybe we'll scale it up a little bit. If I do wireframe, you can see we have our little galaxy, the nested Russian dolls or whatever. What we can do is just merge these things together. So now our triangulated points have not only our random, but we also have this pattern. Then when we do everything to it, takes a little bit of time to cook. But what you can do with these concentric circles is start to like design in or put in some kind of like spider webbing cracks. Kind of like if you're cracking a window, or if you want a shockwave, like a impact, pow, someone bashed the middle of it, you can get more detail and stuff in the middle. So we let our thing cook. So if we look at it here, we have undistorted, undeformed geometry, where it's like you can't really tell what's going on. But if we look at the random primitives, then you can see we have this spider webbing or whatever. So if we had like a baseball getting thrown through this, or we had our this guy's always a good one to have around. This default frame range of side effects, they always cut off 240, like 10-second frame range. But we had this guy hitting this, making a shockwave or whatever, then we could fracture it in an interesting way so that we get a lot of detail in the middle, and then this extra stuff is just residual stuff that they could split up or something like that. So I think right now it's a little bit, these spheres I'm using are a little bit too high of a resolution. You could see it was just it took a little bit longer for that fracture to get generated, and then the overall shape was just a little bit too like rigid or too realistic. I mean, too unrealistic. Like it looked too repetitive, I guess. We can also scatter. So if I just do 10, and then I'm just going to do a transform, slide this down to be two-dimensional, scale, flatten out Y completely. This way we can kind of further break up that repetitiveness or uniformity of the cells inside of that circle. So that scatter right here will get some extra little slivers and stuff like that. Or we should start to get more of them. So I increased it to 65. Seipu, how's it going? Yes, I remember. It was like two or 3 months ago. It's good to see you in here. So that's what we're doing with this guy, is we can... Yeah, it's hard to... It was like right before the lockdown and everything like that. Kind of lost track of time after... Could be 1 month, it could be 4 months. Nobody really knows. So that's what we're doing with these extra guy right there. Pop them in, and we get some more randomness for our just fracture distribution or whatever. So we'll take this is like a pretty good starting point. Yeah, I'm still working at the same place. It's kind of fully remote right now, so it's not nice. I don't know. I kind of like having like an office and stuff to go into, or a different place, but it's all right. So I'm gonna go into poly extrude, and then what I'm doing for this is we're just gonna give these pieces some thickness. You can do distance. Sometimes I find that this, like based on normals or stuff like that, you get some flipping. Yeah, thanks for coming by. Thanks for checking this out. Sometimes you get some flipping, like the distance they go the wrong way. So usually what I do is I'll go under transform and then just set that to global, and then you can be sure like which direction everything will go in. And then I'm just gonna set this extrude back. So if things are flipped around, we could go up. This is like the tinted back face or whatever. That just means the stuff is inverted. You can also fix it with the reverse node. I'm just going to make this stuff a little bit thinner. I don't know, it might be more realistic or whatever. We have this pieces now. We're ready to go. We can assemble them. And what we can do here is take our DOP network and just keep making another copy of it. Oof, something happened. Maybe that was just a temporary error. Oh, okay. So I think it just didn't have packed geometry. I'm gonna turn off that ground plane. It looks like everything is working correctly now. So this, what we're gonna do here is do like a more gradual version of this kind of velocity injection. So instead of just being on the first frame over a duration of 10 or 20 frames or something like that, we'll propagate outwards our burst or our explosion or whatever. So we'll do that in a second. I'm just gonna refill my water. I'll be back in just like 1 minute. Let's get into it. So if we just play this, we have a bunch of problems. No ground plane, everything's falling down at the start, all of that stuff. So I'll add the ground plane back in. This guy, I just have it hidden or whatever. And then when I do that, you see that there's this flickering issue or whatever. Under this object, let me see if this... So I'm just basically doing everything except any object that starts with the ground or whatever. Because I don't want to pull the ground plane back in. So we have some flickering. That can be happening if we just go into our front view Like we're working below the ground right now. Thank you. Yeah, I'm trying to put in some music. I don't know, just to keep it a little bit more lively or whatever. So everything right now is below. Like if we look at the Y position, we have negative numbers. Easiest way to fix that is just with this match size. I'm just gonna do it before we pack things. So you can see when I turn that on, what this is doing is it's trying to center all of the axes so that the centroid is at 0, like 0, 0, 0 or whatever. If we go back into perspective, you can see the little shift. So I don't want to change X, I don't want to change Z, and then Y. If we just do minimum, what that does is it makes sure everything is exactly on top. If we want to add a little bit of a buffer for bullet or whatever, sometimes computer graphics or whatever, like things you don't want stuff exactly on top of or exactly lined up. So now when we play it, there's like a little bump where they settle in, but other than that, they're above the ground and everything like that. Yeah, this is like the dojo, the Karate Dojo song. I don't know what kind of instrument that is. It's some kind of plucked guitar. So we have our pieces, we have the ground working, and now we'll get into the velocity injection and stuff like that. So earlier I was talking about we had this inherit velocity from point velocity. So the way I was setting that up before, we make a copy of the geometry in the other input and then template it. Basically what I do with this is I use it like it's a slingshot. Everything down here wants to aim or go in that direction. So I basically make this a velocity and set it equal to this point minus the position of the point in the second input, depending on how you're counting or whatever. So you do op input 1 underscore p. And now we have velocity information. Sometimes I do the add sop under here with just points. Now if I visualize it, you can see we have our directions. If we scale it bigger or go down or whatever, then we can change the angles. This is why I was saying it's like a slingshot or whatever. We're basically saying go from my current point position and then the subtraction to the position of this input. So you subtract 2 vectors or 2 positions. It's like from minus 2, and then you have a vector pointing in that direction. Yeah, it's a super, I don't know, tried and true web method or whatever. It's kind of old school or whatever, but it's something that just works pretty well. So now if I play it, oof, I think I led you guys astray. I got tricked. These classic velocity vectors in Houdini that are not pointing in the direction they're heading, but instead are streaked in the direction that they're like moving towards or whatever. So now when I play it, you can see we have it. Everything's moving out. If I want stuff going higher, I can just raise that up. But we don't want everything moving at the start. What do we do now? So if we go into packed object, you can see this we can control from point velocity, but we also have initial object type. So we have static objects, animated, deforming, all of these. This you can control with a point attribute as well. is actually called static, animated, and deforming, is 3 different point attributes. If we go back to this, Mr. Shades of Orange did a, whoops, don't leak too much stuff here. The Shades of Orange did a nice retweet of this information that I had. If we go to bullet under fact RBD, these are the 3 that I'm talking about here: active, animated, and deforming. You can control the different states of your pieces with this point attribute. So if I just make a new attribute here, create, this one's going to be active, and then it wants to be an integer. Because it's either 0 or 1. We don't need to worry about the fractional decimals or anything like that. So now with everything at 0, when I play it, you can see nothing happens. So what this does is we have the velocity information on the points, and then we have the active set to 0. So if we go into our simulation, now we can activate them over time and use that velocity when they become active, essentially. That makes sense. It sounds like a good plan. We'll see if it works. So we could do a pop wrangle. You can also do geometry wrangle or whatever. It's kind of it's all the same thing in this sense. What I can do here, if I just do I guess I don't have any presets or whatever, but let me think of a good way to do this. So before I do that, I'm just going to go up here to prototype stuff on the actual points, so you could visualize it a little bit easier. So if I set my color, we'll do it by a random value based off of the point number. So we have a random color for all of the points. Confetti, we have a party. Instead of a random color RGB, I can just have a random value. If I put float, just tell it to generate a random brightness or intensity, kind of. So R and GB, they're all the same value now. And then what I can do is look at this value over a certain segment of time. So right now they're just all random numbers between 0 and 1. But I might want to fit them. So let's say these guys go from 0 and 1, and we'll remap them to 5 and 25. So everything's pretty bright right now because we've gone beyond 1 in this sense, but it's okay for right now. I'm just gonna rename this. So this is going to be the trigger. And what we're gonna do with this numbers is change it so that when the frame of our animation is past this, they turn from black to white. So we'll do trigger minus equals the frame. We got it? It's in there. So we have color, and then we can set that to the trigger now. So as I play it, we're going from white to black. I think we can go. Let me see what happens if we do plus. So So now we have these numbers here that are going from positive, the trigger frame, to negative numbers. But we have the fractional issue. We want these to be integers because we want to use them for this active value. So what I can do, instead of setting it directly to trigger, I can just compare and say, is it less than 0? So now we have just 0 right here, and then 1 over time. So hopefully that was a good, it's kind of a complex, a bunch of steps or whatever, but hopefully that's a good concept. So we'll just copy this code, and I'm gonna paste it in this wrangle right here. And then instead of the color, we'll just set the active value to this. So they're activating over time. If we want to inspect it, we can do maybe another add down here. And sometimes I'll just break things down with these colors, just to be certain that we know what's going on. So if we do ramp from attribute active, then we can see they're going from this 0 to 1 over the duration of time. So the other thing we want to do is take a look at this active value and say, at the start, we'll say state, and we'll record what that value is before we override it or set it. And then we can look at this state and say, if it's not equal to the new value that we're setting, basically like if it's changing from inactive to active, we'll add the velocity. But unfortunately, like as the solver works over things, it's erasing the velocity from the input. So we could, just gonna bypass this for right now. We can get information from input geometry using these nodes up here, these inputs. So if I do this and set it to first context geometry, that's the same as this one over here. I'm gonna do it using input number 2. So it's a little bit complicated or whatever, but that means that I can do at up input 1 underscore v. So if I set this one to myself and then just did up input 0, this would be the current velocity of the simulation. And then this one, let's see, it doesn't seem to be working yet. Let me maybe this needs to be 2. Let me back it up a little bit. So we'll do just changing the color to 1 if this condition is met. Then I just need to disable that visualization. So something's gone amiss. I've done something wrong. We were doing so well up until this one thing happened. We have active, we have this. All right, I have a better idea. Instead of setting this, let's just make up a velocity. Did I overwrite the attribute in the pack geometry? I don't think I did. I was doing all this stuff after it's become packed. So I don't think that. So I'm just doing a test right now, and basically saying, instead of trying to fetch the geometry from the input, I'm just going to inject a constant vector. I'm trying to, the attribute exists on this input. Might just be my syntax. Sometimes that op input shortcut doesn't work that well. So in that case, like this point function can work a little bit better. So we'll do 1 for this. These orders or whatever is a little bit confusing, but it goes from 0, 1, 2, 3, and then get the velocity and then match it based on the point number. So now it's working properly. I don't know why that other syntax at op input _v should work. I think it. Let me inspect something. It's working here. I don't know. This is a little bit untrustworthy, I think. It's kind of like a shortcut, but it doesn't. This function is a little bit more trustworthy to use, I would say. So basically what we're saying is if the original state isn't the same as what we're making the new state inject or grab the velocity that we've assigned to these input points. So we can play this. And instead of random, we want to do like a radial ripple kind of thing. Like this guy. This was the trigger, and we're activating them randomly. So you could see like each frame, boom, 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 random ones are turning on. So instead of doing it based off of a random number, we can do the length of p, the point position, and then you can see it's growing. And then we just need to make sure we're remapping it properly. So instead of going from 0, instead of taking the source range of 0 to 1, we could go the source range of 0 to 5. So let's just give this a try. We'll copy it. We'll sometimes I'll leave that code in there if I want to go back to it. Put in a trigger, just overwrite it with our new values. Then you can see we have our new animation or whatever working properly. And then the other thing that's weird is just that this force is getting more powerful over time. So that's happening because just the uniform scale, like the distance gets kind of exponentially bigger or whatever the farther that things get. So one thing we could do is like normalize the vector. This will just disregard the length or the magnitude of it. So when I play it, it might not even be strong enough. Let me try multiplying this. So that was a bit too strong. So what I want to do is decouple this length, and then I'll multiply it again by maybe this mask. So let's take this velocity and multiply it by that range. But instead of going from 5 to 25, maybe we'll go from 1 to 0. And maybe we'll go higher, like 10. So what this is doing is saying where the distance of my position from the origin is 0, make the value or the length of the velocity 10, and when it's 5, multiply the length of the velocity by 0. So now we have a somewhat interesting, somewhat broken thing, but it's working. The motion is working properly. So it's possible this fancy distortion stuff I was doing, this is breaking the collision geometry. So I just disabled that distortion. Now you can see it's a little bit, kind of looks a little bit more stable. This is like somewhat of an issue with the bullet solver though, is that the penetrations, when things become active, like it can cause things to blow up a little like that. One thing we can do, I'm just going to go back to the broad kind of layout. Maybe we want to do more, that might be too many. So let's let it do its thing and see what happens. So I think this is kind of what Shades of Orange was talking about earlier, where like you find the one piece that's behaving unrealistically, you can do the blast, individually blast or kill it, hand animate it to fix it, or just run multiple simulations to kind of get around it. What I'm doing here, I just did a higher fracture pattern or whatever. Still have some that are a little bit unrealistic or whatever, but we'll keep going for right now. So instead of going up to that high of a range, maybe we'll just try 2. We can change our minimum and maximum values. I don't know why this is getting like a stair-stepping effect. I don't know if it might be that the velocity is like getting messed with too much. Looks like it's, oh, I know it's happening. So basically, as because I did this based on the length, the distance of the position from the origin, like as the piece is moving, it can meet or not meet this threshold based on that problem. So to get around that, you could just do a rest. We don't even need to do that, maybe. What we can just say is the position And we'll get that from the source of our DOP network. So instead of getting the velocity like we were doing earlier, we'll get the position. And then that solves that issue. So that was happening, if that makes sense, because we don't want to take the current position. We basically want to look at the position as it is before the simulation. So hopefully that clears up that issue. Makes sense to people. So with this position, this is like, maybe it's maybe clearer if I say source, SRC or whatever, source position. And then maybe with this velocity, instead of just doing, it's kind of boring that these things are flat. So instead of just V, what we can do is work with another one that's the W. If you remember earlier, I was talking about velocity. We have velocity, but we also have angular velocity. So we can add just a random, I usually do sample sphere. You could do maybe direction. I'm gonna stick with sphere. Sample sphere uniform. And then this one, I'll usually input another random into it and set that just to point number. So basically this sample sphere uniform wants two inputs, like a U and a V coordinate. So I just take the point number, and then using this random function, it's giving two values to the sample sphere uniform. And then if you play it, you can notice like a slight jitter or whatever to these. They're no longer completely flat when they're going like straight up. But if you want them even more interesting or whatever, you can just multiply this W vector by a bigger value. And then you see we have more of an interesting thing happening when they blow up or whatever. The other issue we have now is that like even beyond the initial burst, because we're making a random vector, the ones that weren't getting any velocity added to them, we're still getting a random value added. So there's a couple different ways to fix that. What I'm gonna do is just multiply it and take the length. So basically, depending on how strong a velocity we're adding, only rotate or randomize the angular velocity by that amount. We have a party kind of happening in the middle. You might want to tone that down. Let's see what happens. Our angular velocity might be too high because this number here can be more than one, or can be pretty high. So now we have something somewhat interesting. What do you think? Some things I do sometimes to help it out is like a pop drag. Just a small amount. Kind of can fix some of those big issues. And then some of these ones that are like twirling around forever. Yeah, I don't know how much. I feel like the Vex might be hard for some people to follow along live, or it might be a little bit intense. I also do drag spin, and then if you do a very small number for this, it will kind of fix some of the ones that tend to butterfly or spin around for forever. Yeah, I think it's easier once you have the actual files to follow along with the Vex. Because going live, like I feel like you don't have copy paste. You can't like follow. You can't read this long enough or whatever. It's probably hard to read on the stream. So there we go. We have something. If we want to visualize things a little bit better, sometimes I just do the unpack. That's like a display issue or whatever with the normals, just when they're packed. So you can ignore that. And then you just want to ditch the color. If we go to primitive, we just delete color. Now we have something that's like a little bit more, somewhat more realistic. This velocity we're adding might be a little bit strong. I'm just gonna get rid of that a little bit. Some of these guys are a little bit goofy. It's possible you might want to like clamp the maximum speed. So it's playing a little bit slowly right now just because it's like a lot of geometry to unpack. What I'm gonna do is add in these other fracture points that we were working with, so we have more of our stylized shape. So we have our spider web or like detail happening in the middle of the shockwave or whatever burst or whatever's causing this this event. We can try let's add in this VOP. This was doing the funky like distortion warping. If we go back to wireframe, we have some splinters or detail like that happening. So you get some cool results with that. You might want to work a little bit more with these. I'm going to increase the rows on these source spheres, so we just have more tiny pieces in the middle, hopefully. So now we have like a lot of little slivers or tiny pieces. So pretty cool results. Let's change some of this around. So one thing I'm gonna do is just do a jitter. So if I do a jitter here, basically these targets that things are trying to find, or if we look at the velocities, the amount of jitter we apply to the like destination slingshot positions gets jittered as well. So we have some randomness in the direction that we're trying to shoot things when we activate them. Let's just give that a play. And then I might just want to make these stuff a little bit stronger. Let's go up to 15. I feel like it's pretty cool. I feel like it's a bit too high. It's like maybe if this was like if something was detonating, like a mine or something like that. But we can change it. So if I just decrease the height, sometimes what I do is another add and then a template just to visualize this point cloud. So instead of moving things up, and then even on this jitter, I'm gonna reduce the amplitude just in the Y direction. So now we just have a straight, like, outwards. Things still go up because they bump into each other when they become active. But this way we're able to solve that issue of, like, everything flying way up. Let's go maybe a little bit lower than this one, just a 5. So now this is a little bit closer to that. Where did it go? Let me find something real quick. There's like that manga. What did you? Mr. Shades of Orange was calling me a weebo. A waifu. So it's kind of close to this style a little bit, where things are just gradually, like, getting released or falling apart. We could try. Maybe we want to try lifting all this stuff up a little bit. See what happens with that. So then we have everything kind of like sinking or falling apart. Would be a cool effect. Trying to think of an easy way to not release some of these outer portions. I think we could do that using some information that we currently have. Like, we already have these velocities, and basically we could say anything that we're not trying to add velocity to, because we've masked that out using this radial fall off right here. We could use that as another parameter or function of our vex over here, to modify the trigger. So I could take the length. This guy, we're finding the length of the input or source velocities. And then I'm just going to multiply another comparison here and say the trigger is less than 0, so that's either going to be 0 or 1 depending on the time, like as this frame increments. And then the multiply right here is going to add another mask, or we're combining another conditional. So we're going to look at the source velocity vectors and say, are they bigger than 0.05? We could even go smaller. Like, you don't want to compare against 0. It's just not a good idea with, like, non-integer numbers. But this is going to be our second comparison. So we have the one thing here that, as this frame is offsetting, the trigger value will go below 0, and when that happens, this code right here will evaluate either to 0 at the start of the simulation or 1. So that's what was originally activating things, and then multiplying by another condition that's going to be either 0 or 1. So we have a syntax error. Let's see what's going on here. I think I got carried away with my parentheses. We just needed one more right there. Like 1, 2, 3, 1, 2, 3. So now when I play it, you could see we were able to freeze those original pieces, such that they're never going to be released or move or anything like that. We might want to play around with this amount that we're lifting things, maybe just like 0.1. So this is more of like just a collapse, kind of like your, I don't know, this could be like a road or a street pavement or something like that. It's like there's like, I don't know if it's like the crest of the earth or it's like how far things can drop, depends on maybe if this is like a paved road or something like that. Could be something happening underground or something like that. Yeah, some nice colliding geo. It's a good idea, Alex. Yeah, so using the terrain, that stuff that we were doing earlier, making an interesting terrain object, and then just using that height field to collide against, then you could have a nice kind of sloping pattern or something like that. You could also hand model some smooth shape or something like that. Let me see. I'm trying to think of an easy way to do something like that. One thing I'm going to do is just increase the count of these points just to get a more dense distribution. Sometimes I visualize stuff using like this wireframe. Just to see like the fall off or stuff like that, how just a more like interactive way or whatever of setting things up. You like generally gauge the size of the pieces in like more real time or whatever. So this fracture takes a little bit of time to perform this operation. So we'll just let this guy cook, chop away, cut away. I'm trying to think of a nice way that we could get like a interesting sinkhole pattern. Unfortunately, I'm not, so it looks like this thing just finished. I'm not super professional or super good with the, so now we just have more detail and more pieces and stuff like that. I'm not super good with the terrain tools. It's a little weird at the end how those things fall like that. If we had more of a crater shape underneath or whatever, it could be a little bit better. What is it? So I think with these terrain, like I feel like there's maybe this project. This is kind of what I want to do. Let's see if we can get it going. So I want to make a height field. The default size is a bit big for this circumstance. And then if I'm reducing the size, I need to reduce the grid spacing. So I think that's okay for right now. And then let's see what happens. It's going the wrong way. Should we just do the laziest approach to fixing this? Let me see if this works. Height field transform, height scale -1. Boom, we did it. So that would work too, Alex. The soft transform extrude volume. I think we did it. I think this one's going to work out okay. So that's going to be our little crater, the lazy boys approach of doing this. I'm going to decrease the grid spacing just to get a little bit higher resolution. maybe let's take, I think we could do something interesting here. So I'm going to turn this into a polygon, more resolution. Let's see what happens with this mountain. Now we have something happening. Take it easy. Have a good night. Thanks for your all of the advice with the small pieces. Solved all the issues. You have you still preserved your perfect record of never being wrong. So I think this is let's just see what happens. So we'll get this going with our terrain. It's sad. Let's just sub that out, and I'm gonna turn that off for right now. Just hide that visualization. SOP path here will be op input path of, we want to look at the parent network or parent node, and then the next input, secondary input. We want to use a height field. I got my numbers wrong right there. So if you just do middle mouse on these, you can double check to make sure it's evaluating the path properly. So we have a height field. Collisions should be good based off of that. It's possible we don't need to do that lifting anymore because we've drilled a little hole into the bottom of that. Let's just play it, see what happens. I'm gonna switch to my my better professional visualization. I think we can speed things up too, because this is a little bit slow having to unpack everything every frame. So the big reason that this stuff is happening when you pack it is just if you don't have normals on your geometry. So if I add them before packing it, we're good to go in that sense. And then I'm just not going to apply that color randomization. So what those changes are doing, if we just reset the simulation, now we can play things back and it's a lot quicker because every frame we're not like unpacking and deleting attributes. Let's take another look here. Boom. It's pretty cool. Gonna update our mask here. So we switch to height field, so I could either do everything except stuff that starts with, what is it, terrain? Okay. So everything except objects that start with ter. And we end up with that. So we get some interesting things with this stuff rocking back and forth. Might be able to reduce this grid spacing even more. Do some yeah, thanks guys. You guys this is Alex's good idea of adding in the little sculpted interesting collision stuff for things to lie on. So I'm just trying to get a little bit more interesting of a crater, whatever kind of shape we're making here. Sinkhole. So maybe like higher resolution could be a little bit more interesting. And then, like, now that we have an interesting shape, we probably don't need to rely on flinging stuff around as much. So I just delete the incoming velocity. And now we have something a lot closer to our reference if we want. Just the gradual fall away. Here we have... You originally a colorist, Alex? Oh, the color commentary. I thought you meant, I don't know if you mean a colorist like a Da Vinci? Doing the color correction. So now we have this stuff falling around into our crater. It's pretty cool. We even have like a little bit of cracking happening because I think our crater isn't exactly big enough. So if I make that smaller, you can see that basically what we're doing here is like just a super small sinkhole or divot. So this is another way that we can kind of art direct stuff. So this pavement or whatever we're calling this stuff will still get cracked and shifted around a little bit, but it just doesn't, like, we just see the cracks, but we don't actually see it fall down. So maybe play around with this a little more. Maybe visualizing this one's a little bit better. And I'm just gonna make it a little bit flatter. So now we can have it lay down in a pretty interesting fashion or whatever. So let's just work on our fracture a little bit more. This is like that repetitive uniformity or whatever that I was talking about that looks a little unnatural. I mean, it depends if this was like a certain type of crystal or some type of rocks. You expect to see this like repetitive structures, but for this circumstance, I don't think it's helping us that much. It's like this weird stuff happening there. So what I'm gonna do is go into here. You kind of see them in the source triangulated geometry. I'm just gonna get rid of those, and I'm gonna add using this scatter. I'm going to switch the scatter so that's happening before our copying. And I'm going to merge it in. The reason I'm doing this is because, like, if we just scatter after the copying, it will just evenly distribute stuff across the copies. But I think this, what I'm trying to do is like bias these scattered points so that we have more of them in the center of things. You think a mountain here will help? I think that's a good idea. Let's pop it in. So let's see, this transform flatten. I'm going to do that down here. It's just... So I think I can do the mountain maybe at the end. So let me get some better results. Because this, doing it after the copy, then we'll just get unique results for each copy. Let's see what we're getting now. I think this was a poor idea. So we'll do the scatter at the end. Maybe the jitter to the scattered points. Just every kind of randomness that we want at our we're doing mountains, we're doing jitters, we're doing so maybe I'm just going to do a transform on this chain but shrink down the scattered points. So we're doing a ton of stuff now. We have the scattered, we have the main copies. Maybe this is, maybe it's good. Let's try it. Let's give it a try and see what happens. So we're just going to try a few things now, hack around, get a little bit more interesting of a fracture distribution, and then probably wrap things up. We're getting a little bit close to the too long mark. Uh-oh. So if you just have an old cache or whatever, it can kind of get corrupted. So refresh the cache. It's looking a little bit better. Sometimes you want like some structure. Even in this, you can kind of see he has like some repetitions and stuff like that. It's 3 a.m. for you, Kieran. So sometimes you want some concentric like structures or repetition, especially the anime style or whatever. They like to do more graphic design things or whatever. So it's late into the evening for you. So it's pretty interesting there, and then we just control it with this height field. So it's a pretty good workflow to use. These pieces are looking a little bit thick. I'm just going to decrease that extrusion amount. I think it looks better. It looks a little bit more detailed or whatever when they're less chunky. This is pretty cool. If we want, like, probably makes sense to use some of these other pieces. Like if we're spending all the time to generate the fracture. So I can be sure to use them if I increase this radius. So that was just like our activity radius or whatever. And then we just need to make sure that our punched hole cutout or whatever is expanding bigger as well. I'm going to increase the resolution to get more mountains. Let's give this a try. Might be a little too deep. I don't know. I wouldn't say I'm more important than sleep. So I just want to make sure that this stuff isn't too deep. If it falls, these things fall too far, then it kind of breaks our pattern or whatever. So this is just what I meant by we're using more of our fracture or whatever. It's just more optimized in terms of we're not making pieces that we're not simulating or whatever. We have a nice kind of graphic punched look into things now. It's pretty cool. Boom. Got some butterflies. You guys see it? Like these guys are flipping up and down. So let's go in here. I'm just gonna eliminate our drags. Let's see if that fixes it. Sometimes that pop drag spin. Looks like we still have it. I don't know what the jitterbug. Gonna increase. Oops. You're pretty good for 1 year. Just increasing these drags to try to eliminate the jitterbugs. Yeah, in my college we weren't learning Houdini either, so I had to do like an independent study. I was trying to learn it on my own for a semester, but it's hard. Houdini's a hard software to do without proper instructors and stuff like that. But did we fix the jitter? All right, let's investigate this a little further. Let's reduce grid spacing, increase resolution of height field. Gonna reduce the roughness of that mountain just to get rid of some of these little divots and stuff. Maybe just the element size overall. Yeah, it's Houdini is definitely a tough software to get your head around. Kind of need a shaman to to guide you through the treachery. So let's examine again and see if we fixed our jitterbugs. I don't know if this stuff affects it, but you might want to go to the physical properties of the ground. Just turn off the bounce. Even our pieces, we could reduce the bounce, just because these objects, if we're saying it's like earth crust or pavement or asphalt or something like that, we're not expecting them to bounce. So the bounce might have been responsible for adding to the jitter and stuff like that. Let's give this another play and see if we fixed. I don't see too many jitters. Simulation got really slow somehow. Might just be the amount of pieces. 430. Maybe it's when I increased the resolution of the ground plane, the terrain made it smaller, or it made it slower. But it looks like we fixed. Oof, I don't know. I still see it. All right, we're gonna go back up to a higher resolution. Might be that they're quite thin. Sometimes when these pieces get you can see it's a little bit faster now. I think we fixed it. We still have our guy up here. Just gonna toss him in and see what happens. So he's walking around with his hammer. We'll just do a time shift. I think that smash happens around like frame 250 or something like that. If I just subtract, I just want to add actually to offset the other way. 250 frames. Maybe 245. Let's see. 243. Oof. Now he's kind of he's responsible for the mess. See if we can line it up a little bit better. Boom. How? There it is. You kind of, I don't know, maybe like we wanted to really make this into a proper Crag the Destroyer. If we really wanted to make this into a proper shot, like one of the things we could quickly do is maybe just mask out the area that he's standing on so it doesn't get destroyed. Just so he's always on like a flat land. Maybe like all of this stuff just in a radius or like directional thing or whatever. Let's see what happens. Maybe add some of this powerful velocity back in. Whoa, a little too much. Let's go down. So it's pretty cool. Probably gonna end it here pretty soon. If you guys want to play around with this some more, some interesting ideas and stuff to go in. So I'll just leave all this stuff in the one file. We have our actual fun, interesting thing that we did, and then we have our super mundane, complicated, technical fracturing workflows or whatever. This stuff is useful. It's just not, I don't know. I also need to study up on it and prepare some more before I talk about it more. So this will just all be in the Fracture Basic version 1 file. Saved it again. Boom. Just make sure, save it. Yeah, we're probably gonna end it soon. I was doing some more. Thanks. Yeah, I hope it's useful. So I was going and playing around with this guy a little bit. I think like I was finding Vellum to definitely be a lot more stable when you're seemed like at higher resolutions the grain solver tended to blow up a little bit. So if you are still working with this thing from yesterday, I'd definitely recommend just switching things over to Vellum. It's pretty easy because it uses the same point attributes and everything like that. There's a couple of issues I ran into, but for the most part it was it seemed like this issue of the nose flying away, switching to Vellum definitely fixed that. Yeah, thanks guys for stopping by, hanging out, paying attention to me blunder on through all the mistakes and everything like that. For tomorrow, I haven't figured out what it will be. We might get away from the technical stuff some more. Trying to get, I don't know, maybe the more technical stuff, I just need to save those as like offline stuff that isn't, that's more edited or prepared or something like that, but I'll figure it out one day. All right, guys, have a good, Kieran, have a good night after 4 a.m. It's almost 5 a.m. now. Take it easy. See you guys tomorrow.